Hello, Professor. This is my Math 3A demonstration. Uh, First exam one, I chose question one because no particular reason, honestly. Uh, the correct answer to the question was 0, comma 3, and I got 0, comma 6 because I tried doing the question in my head for some reason at the exam room, and I don't know why I did that. A silly mistake, honestly. If I'd taken my time and grafted the intervals on the number line, it would have been, uh, you know, piece of cake. So I did that again, and I got the right answer with it. Um, yeah, it's just a dumb mistake, easily avoidable. Shouldn't do it again. For exam question two, I sorry, not exam question two. Exam two, question six. I completely got that wrong, so I redid that. I got it wrong completely because I just didn't know how to do it at the time, honestly. But I know how to do it now, so I just did it now again. Um, Zoom in so you can see. So yeah, if I want to get this one right, next time I should have just been more prepared for that exam. Uh, I was not. I don't think I was managing my time that well. So that's what I would do to get this question right for the first time on the next exam. So hopefully that doesn't happen again. Now for question three, I believe do the bisection method on problem 5 from exam 2. Approximate the zero till the error is smaller than 0.05. Now this is a bit complicated, but I think I grasped the concept pretty well. Where so the equation is x to the third power minus x equals 4. Now the first two numbers I used were 0 and 2, 0, comma 2. Uh, so I got f of 0 equals 4 and f of 2 equals negative 4. So I decided to make a, well, I didn't decide. A in this situation would be 2, and B would be 0. The reasoning is because A should be the smaller number. Basically, I inputted that into the equation of A plus B over 2, and I got 1. So then I plugged 1 into the original equation. I got 4. No, actually, what did I get? Yeah, I got 4. Sorry. And since 4 is a positive number, there's a rule that basically means that any number that's if f of p is basically greater than 0, the b gets replaced. So the b is the new f of p. So basically, f of p is b, and so now your a stays the same. So it's a equals 2, b is now 1. So now we plug that back into the equation. We're going to get 3 over 2, which equals 1.5. F of p is now 1.5. We plug that into the original equation, and we are going to get 1.5 to the third power minus 1.5 equals 4. That's going to be 2.125, which is greater than 0 again. So we go back to that rule where if it's greater than 0, you're going to replace it with the b. So now we have a equals 2, b equals 1.5. 2 plus 1.5 over 2 is 3.5 over 2, which is 1.75. Now, 1.75 is just going to be the correct answer because if you plug the original equation of x to the third power minus x equals 4 into an online calculator, you are going to get approximately 1.7963. 1.7963 minus 1.75 is going to get you 0.04, which is less than 0.05, which is what the problem asks. It asks you to find, approximate the 0 until the error is smaller than 0.05. So that is how I got that. It is smaller than 0.05. For the fourth problem, let's take a look. Explain how to find all the vertical asymptotes and horizontal asymptotes of the following function to receive full credit. So you'll explain without using a graph, then using limits. Alright, first. For the very first one, finding the horizontal asymptote, I used the basic limit laws of having x approach infinity, and then I applied that to the function to get the answers 3/4 for the horizontal asymptote. For the second function, I first found the domain and the range of the function. In that example, it gave us 1/0, which is an indication that is an infinite limit. And then I got x equals 1 for the vertical asymptote. So since the denominator cannot be 0, we essentially solve to find the domain, and then we use limits to find that answer. For the final one, arctangent of x minus 2. Basically, I've found the domain and the range of that function, and you basically have to restrict the domain and inverse the function, and so then I flip the domain and range. If there's no domain restrictions, there's no vertical asymptote for that one, and then I just used limits to basically find the horizontal asymptote of that, which was y equals pi over 2 minus 2, and y equals negative pi over 2 minus 2.